Section 8.3, it's called equations that lead to quadratic methods. So, first thing I want to do to get started is just review. And say I asked you to solve 4 over x minus 1 plus 9 is equal to negative 7 over x. We have seen problems like this before, but they never turned into quadratic equations. So does anyone remember how we solve problems like this? We have to find the LCD first, and then we're going to multiply everything by the LCD. What would the LCD be here? We definitely need an x minus 1. And we definitely need an x. We multiply everything by that LCD like we've done before. It'll get rid of all our fractions, and then we could go ahead and solve what's left. So I'm going to take the time and write x times x minus 1 times 4 over x minus 1 plus x times x minus 1 times 9 is equal to x times x minus 1 times negative 7 over x. Whenever you multiply and divide by the same thing, they cancel out. We just get 4 times x plus 9x times x minus 1, which we'll distribute in a minute. And then this x cancels with this x, and we just get negative 7 times x minus 1. Just distributing here would give us 4x plus 9x squared minus 9x is equal to negative 7x plus 7. And just like we talked about in our previous section, we have to set these equations equal to 0 to solve. So if we go ahead and make it equal to 0, we're going to add 7x on both sides. Subtract the 7 on both sides. And it looks like we get 9x squared plus 2x minus 7 is equal to 0. Just make sure I added all of those correctly. I think so. So the next question is we have to factor what numbers multiply to be 7 times 9 times negative 7 is negative 63. What numbers multiply to be negative 63 and add up to be 2? Negative 7 and 9. Yeah. Go ahead and finish this. We just get 9x squared minus 7x plus 9x minus 7 is equal to 0. Cutting it down the middle, we can take out an x, and we're left with 9x minus 7. Take out a 1, we're left with 9x minus 7. So factored, we get x plus 1 times 9x minus 7. Or x plus 1 is 0, so x is negative 1. 9x minus 7 equals 0, so x would be 7 over 9. The one thing we just want to check, let me just pull up the original equation here, is we want to check for extraneous solutions. We've talked about this word before, extraneous solutions. And extraneous just means extra solutions that don't actually work. So even though we did all the math correctly, sometimes with absolute value, you wind up with an answer that says the absolute value of x is equal to -2. That doesn't make any sense. Absolute value can't be negative. You want to check absolute values to make sure that they work. The type of problem that we run into issues with is if we have radical equations. If you had the square root of x is equal to -3, that's impossible. You can't take the square root of a negative number and get a negative answer. It doesn't work. The last type of extraneous solutions are rational equations. If you ever get 1/0, that's a problem. That's undefined. So when we're doing these kind of problems, just double check. If we plug in -1 to our denominators, it's not going to get 0, so that's fine. And if we plug in 7/9, that's not going to make our denominator 0 either. So it looks like both of those answers are correct. When you're doing your homework, you might do everything correct, and then you go to plug them in, and it says you got the wrong answer. That's because one of your answers doesn't work. One of them is an extraneous solution. So just make sure you check. All right, let's move on to our second example. And second example is a word problem. It says in 1 3/4 hours, Cody rows his boat 5 miles upriver, and then back. The rate of the current is 3 miles per hour. How fast does Cody row? Let's figure this out. And this looks like it's going to be a distance equals rate times time problem. So we just have to get organized a little bit. When we first saw these distance equals rate times time problems, we set up 2 different equations. One is if we're going upriver, and the other is if we're going downriver. You know that going downriver, we're going to go a little bit faster because the current's pushing us along. So it looks like up the river, the distance would be 5, and the speed would be whatever speed we're like rowing. But if the current is 5 miles an hour, how are we going to adjust for that? What would be the speed going upriver if we take the speed that he's rowing exactly right. Upriver would be r minus 3 times however long it takes to get up there. That's exactly right. That's the hardest part. Going down the river, it's the same 5 miles, but you're adding 3 to his rowing speed. And I have no idea how long that's going to take. But the total speed, let's see here, speed downriver plus the speed, I'm sorry, not the speed. So the total time going downriver plus the time going upriver is equal to 1 3/4 hours. In order to solve for this, let's figure out what the time is for each of those equations, add them together, and then try to solve that equation. To isolate t, we're going to divide both of these by r minus 3. We get the time going upriver would equal 5 over r minus 3. Going downriver, we divide both of these by r plus 3. Be 5 over r plus 3. So let's combine both of those. The time going down the river, we said, was 5 over r plus 3. The time going upriver was 5 over r minus 3. That's equal to 1 3/4. It might be easier if we just write it as 7/4, so that we could solve this as an equation, just like we did in the first example. Give us a little bit more room here, a little more screen space. In order to solve this now, we have to figure out our LCD, and then we're going to multiply everything by that. What would the LCD be? R plus 3 times r minus 3 times 4. It's going to take a little bit of time to multiply this out. You guys could go ahead and do it on your own. You don't have to wait for me to do this. And once we have it all multiplied out, we'll make it equal to 0, and then we'll solve it. So it's just going to be a lot of writing here. I'm going to multiply by 4 times r plus 3 times r minus 3. Multiply that by 5 over r plus 3. Plus 4 times r plus 3 minus 3 times 5 over r minus 3. Equal to 4 times r plus 3 r minus 3 times 7 over 4. Let's go ahead and cancel out the r plus 3s, r minus 3s, the 4s, and let's multiply what we're left with. 4 times 5 would be 20 times r minus 3. Plus 5 times 4 is 20 times r plus 3. Equal to 7 times r plus 3 times r minus 3. Multiplying this out, we get 20r minus 60 plus 20r plus 60 equal to 7r squared minus 63. So we can cancel out the 60s, and let's try to get this on the same side. So what I'm going to look to do is I'll add these together, and that would be 40r. So I'm going to subtract 40r on this side and on this side. Giving us one equation, we just get 7r squared minus 40r minus 63 is equal to 0. If we were to multiply these, so we factored, 7 times negative 63 is negative 441. We have to add up to be negative 40. This is going to be one of those times where it's just going to take a little while to land on those numbers. If you start at 441 and look to see what factors multiply to be that, we get 3 and 147. Obviously, those aren't going to add up to be 40. 7 goes into 441 63 times, but that's not going to work either. But if you try 9, 9 and 49 are going to work. So we would just have to make the 49 negative and the 9 positive. We get 7r squared minus the 49r plus 9r minus 63 is equal to 0. Cutting it down the middle, we take out a 7r. We're left with r minus 7. We got a 9, and we're left with r minus 7, just like before. We get r minus 7 times 7r plus 9 is equal to 0. Making these equal to 0, we get r is equal to 7. 7r plus 9 is equal to 0. And I remember in the last class, Nick, I believe you asked a question when we're solving quadratic equations, sometimes will we get numbers that don't work or that don't make sense. And I started explaining that it is possible to get like negative times or negative lengths, right? So this would be a really good example to demonstrate like the answer to your question. So remember what we're looking for. We're looking for how fast Cody's actually rowing. Well, one of these answers doesn't make sense. So, the answer would be 7. Have one more word problem, and then there's just some random algebra problems I wanted to finish with. All right, let's say 2 chefs are preparing for a banquet. One chef could prepare in 2 hours less than the other. Together, they can complete the job in 5 hours. How long would it take the faster chef working alone? So similar to the problem we just did, but it's not like a distance equals rate time problem. This is a work problem. We've seen this kind of thing before. Instead of distance equals rate times time, the amount of work that you do is equal to how much you could do the rate times the time. We've seen this before with painting. Talked about actually a friend of mine, his name's Jariel, married to a woman named Winnie. I remember that problem because I made to incorporate him. But I said if Jariel can paint a room in 5 hours, Winnie can paint it in 3. How long will it take if they work together? You guys remember doing that? Maybe we can. So for this particular problem, let's get it set up with our 2 chefs. So call it chef 1. This is the slower chef. And let's call it chef 2, is the faster one. The question is, how long would it take the faster chef working alone? So we want to try to solve for t. That's what it's asking us for. Well, in order to solve for t, we have to have an equation that has t as the variable. So let's say that to prepare for a banquet, this is the job. One job. So our equation would say the work is 1. Because it's 1 job. If we're going to get an equation with t in it, we want to solve for r. The whole reason why we're doing this is because it's asking us how long will it take working alone. So our answer is going to be t equals a number. So we have to manipulate this problem to have t as our independent variable. So what I'm going to do is I'm going to divide both sides by t. And I get the rate is equal to 1 over t. So setting up, we're going to do rate times time for each chef and set that equal to 1. So for example, the rate of the slower chef is going to be 1 over, it says 2 hours less. So the slower chef is going to be however long it takes, 1 over 2. That's his time. And the faster chef is going to be 1 over t minus 2. So you take the slower chef's time and you subtract it by 2. The time that we're using for both of these, and remember t is however long it takes the slower chef to do it, the time each chef is going to be 5 hours. So if they're working together, equals the work slow chef, the work for the fast chef. Working together, they could do 1 banquet. The work for the slower chef would be the rate of the slower chef times however long they work, which would be 5 times 1 over 2. For the faster chef, it's going to be 5 times They're right, 1 over t minus 2. When we go to solve this, that's going to give us the answer for the time it takes for the slower chef to do it by themselves. So let's go ahead and do this here. To simplify, would be 1 is equal to 5 over t plus 5 over t minus 2. Just like before, we'll solve it by multiplying by our LCD, which is t times t minus 2. Now we just have to multiply and solve. T times t minus 2 is equal to t times t minus 2 times 5 over 2 plus t times t minus 2 times 5 over t minus 2. Let's multiply. This would just be t squared minus 2t is equal to the t's cancel. This would just be 5 times t minus 2 plus the t minus 2's cancel 5 times t. Make it equal to 0. So this will be t squared minus 2t is equal to 10t minus 10. Subtracting the 10t, adding the 10, we get t squared minus 12t plus 10 is equal to 0. This is not going to factor, so we could complete the square, or we could use quadratic formula to finish it. Just by a show of hands, how many of you preferred completing the square to quadratic formula? How many of you like quadratic formula better? All right. So quadratic formula it is. In this case, A is 1, B is negative 12, and C is 10. So our value for time would be the opposite of B, plus or minus the square root of B squared minus 4AC, all divided by 2A. Just be 12 plus or minus. Type that into your calculator. 144 minus 40 is just 104. And we don't really have to simplify the square root. We're just looking to come up with a practical answer. So how long is it going to take the slow chef? That's what t was. So if you add square root of 104, 12 plus square root of 104, and divide by 2, that comes out to be 11.1. That's how long it would take the slow chef to do it by themselves. If you were to subtract, and you get 12 minus the square root of 104 and divided by 2, that'll come out to be 0.9 for the slower chef. One of these doesn't make sense. Because if you remember, the slow chef, their speed or their rate is equal to or however long it takes them is t. And we said the faster chef was t minus 2. Which one doesn't make sense? The one on the left, right? 0.9 doesn't make sense because you can't do 0.9 minus 2. That doesn't make any sense. So the slow chef looks like they would do it in 11.1 hours. And the faster chef would do it in 9.1 hours. I'll take a look at the test and I'll let you know. When I did look at them, the review guide looked very similar to the test. The review guide, the test, there's not going to be any surprises. So I had a couple other questions here. No more word problems for us, but let's say if x was equal to the square root of 9x minus 8, directions are still to solve. So we talked about solving square roots before. What we said is if we square both sides, we just get x squared is equal to 9x minus 8 equal to 0. And this is an easy problem, especially compared with the word problems. This will just factor to be x minus 8 times x minus 1. We get x is 8 and x is 1. That's it. So if we just check these numbers, plug in 8, we're not going to get a negative, so that's fine. If you plug in 1, you're not going to get a negative. Both of those after checking are fine. What about if we had 2x equal to the square root of x plus 1? Well, we learned how to solve radicals. What I told you is we always want to get more complicated radical by itself. Once you do that, then you square both sides. So for this particular problem, let's get that radical by itself and then square both sides. What I'm going to do is subtract the 1. Square both sides. You square this side, you'll get 4x squared minus 4x plus 1, and this will just be x. Bring the x over, we get 4x squared minus 5x plus 1 is 0. Factoring numbers that multiplied before add up to be negative 5 or negative 4 and negative 1. So just like we usually do, 4x squared minus 4x minus 1x. 1 is 0. 4x, negative 1. minus 1 times 4x minus 1 is 0. X would be 1 and x would be 1/4. Let's check this here. If we plug in 1, remember we're checking for extraneous. Plug in 1, get 2 is equal to 1 plus 1. So that's fine. If you plug in 1/4, you get 2 times 1/4 is equal to the square root of 1/4. This is 1/2. And square root of 1/4 is just square root of 1 over square root of 4, or 1/2 plus 1. Doesn't look like that works. That's the only answer for this would be 1. Let's go ahead and do one other topic to finish class today. The last topic is called quadratic techniques. The whole idea with quadratic techniques is that we make a substitution. And then we're going to treat as a quadratic trinomial. I had 4 problems. Let's take a look at this, and I think that'll be good for tonight. The direction is going to be to solve. What if we had 9x to the 4th minus 37x squared plus 4 is equal to 0? It is a trinomial, so we're going to do it just like we usually do trinomials. But one thing I want to show you, we're used to seeing trinomials where it's 9 times something to the second minus 37 times something to the first plus 4 is equal to 0. That's how we typically work with trinomials. So one thing that we could do to make this a little more familiar is instead of using x squared, which is the same thing here, x squared to the second is x to the 4th. We always use this middle term. If you just make a substitution and let y be x squared, it's always going to be the middle term. It's going to be a lot easier for us to work with. We're not changing the value of anything. X squared to the first is still x squared. X squared to the second is still x to the 4th. But this will be 9y to the second minus 37y plus 4 is equal to 0. This is simple. We've seen problems like this for months now. 9 times 4 is 36. Numbers that multiply by 36 add up to negative 37. Negative 36 and negative 1. So finishing this, we get 9y squared 36y minus 1y plus 4 is equal to middle. Just get 1 minus 4, taking out a negative 1, we get 1 minus 4. The only difference with this problem is once you factor and solve it, you get what y is equal to, but that wasn't in the initial problem. So you just make it a little bit easier on yourself to get started. But remember, y was the same thing as x squared. So we just get x squared is equal to 4. X squared is equal to 19. So taking the square root of both sides, get x is equal to plus or minus 2. Well, plus or minus 1/3. The original problem was x to the 4th. We're supposed to have 4 answers, and we do. Or if we had a problem like this, x to the 4th minus 4x squared is equal to negative 2. So bring the 2 over. Make the substitution we talked about, y is equal to x squared. We get y squared minus 4y plus 2 is equal to 0. This one's a little different because it doesn't factor. So just using the quadratic formula, a would be 1, b would be negative 4, and c would be 2. Yeah, y is equal to the opposite of b, plus or minus the square root of b squared times 4ac, all divided by 2a. 4 plus or minus 16 minus 8 is just 8. Square root of 8 does simplify. It's just the square root of 4 times the square root of 2. We wind up getting, if we make our substitution back in, x squared is equal to 4 plus or minus 2 root 2 all over 2. Which we could still simplify. 4 divided by 2 is 2. 2 root 2 divided by 2 is just root 2. Take the square root of both sides, and the answer is a little weird looking, but you just get plus or minus the square root of 2 plus or minus the square root of 2. So it's a little different looking, but that would be the best answer for this problem. You're not going to have something like that on the final. One on the final, you'll be able to factor it. A couple more problems to finish up tonight. What if we had 5 times x plus 3 squared plus 9 times x plus 3 minus 2 is equal to 0? kind of like what we just did, but let's let this be y. So let x plus 3 be y. And it turns into an easy problem. This is just 5y squared plus 9y minus 2 is equal to 0. This actually factors. Numbers that multiply by negative 10 would be just, or positive 10 and 1. We get 5y squared plus 10y minus 1y minus 2 is equal to 0. Down the middle, take out 5y, have negative 1. Y plus 2 times 5y minus 1, or y would be negative 2, and y would be 1/5. So we substitute what y was. Plus 3. We just get x is equal to negative 5. Plug it in over here. X plus 3 is equal to 1/5. 3. X equal negative 14/5. One more problem for tonight. If we had 4x to the 2/3 power is equal to 3x to the 1/3 plus 1. Let's go ahead and make it equal to 0. And just like before, we want to write this as 4 times something to the second minus 3 times something to the first. 0. So the way that we talk about handling this is we always take the middle term. So if we put x to the 1/3 here, x to the 1/3 to the first is 1/3. X to the 1/3 times 2 is 2/3. So it's pretty slick. We can make our substitution x to the 1/3. And you probably know how this is going to go. We're just going to factor. We're looking for numbers that multiply to be negative 4 add up to be negative 3, so negative 4 and 1. 4y squared minus 4y plus 1y minus 1 is 0. Down the middle, take out a 4y. 4y plus 1 is 0. So you get y is 1, and y would be negative 1/4. Now to finish it, we just have to make our substitution. Remember, y was x to the 1/3. And 1/3 is really the cubed root. So one thing we could do to finish this is just to raise both sides to a power that'll cancel out the 1/3. If we just multiply by the reciprocal, we'll raise both sides to the 3/1 power. Wind up with x is just equal to 1. Negative 1/4 times negative 1/4 times negative 1/4 would just be negative 1/64.